So the problem is the minimization problem, and the constraints are shown here. Let's go just try to code it in CPLEX. In CPLEX, we have to go step by step. First step, we have to define our indices, sets of indices. As we have just one kind of indices in here, which is I, uh, we are going to just define it. It's an integer. For indices, we just use integer, so it's int I, and the elements of these indices should be 5. Why? Because we have 5 scenarios, right? So the indices can be something like this. After that, we are going to define our decision variables. Before decision variables, we can define our parameters. But since we don't have such complex parameters in here, we just try to skip this part. So we don't have parameters in here. Sorry. For this part, defining decision variable, our decision variable should be, we should just like try to write down its kind. What is it? Is it an integer? Is it a Boolean? Is it some type of float? Because we want to try to figure out the number of raw lumber pieces, so it should be an integer. But what is this plus sign? As we have mentioned, this plus sign means the CPLEX software should just try to find the positive, the non-negative numbers. That can include something like 0, 1, 2, 3, 4, 5, 6, and so on. So this is the reason that we have put integer plus, int plus in here. If it was something like float, but a non-negative float, we would just try to put float plus. If it was a just float or integer, that it was okay. That if it was negative, we just put simply int, not positive, not negative, and not anything. So this expression in here, dvar, and the xpr, and this subject to. These are typical. You have to write them down in order to define your decision variables, objective functions, and constraints. So these are not like something arbitrary. You have to write them down everywhere in in every one of your um, problems, codings. Okay, after defining decision variables, we are going to define our objective function, which was what? What it was? It was the minimization of x1, summation of x1 to x5. I know I have written it so simple in here, but there's no difference between this one and this one. But what does it say? It says you have to sum up all of the x decision variables, xi actually decision variables from I that is defined in here. I should be an element of I, this I capital, as a matter of fact. And what it does, it kind of acts like an iterator in this part. So it will try to add on all x i's. That would be x1 plus x2 plus x3 and so on. So i's that are elements of this I capital. After that, we are going to define what is the type of our objective function, which is a minimization. So we will write down minimize z. And then we are going to define our constraints. The constraints, we had 3 types of constraints. You may ask about this one. I will answer you at the end of the programming part for this Question. Constraints, we have written the three types of constraints. There's no difficulty in writing down any of these constraints, as you can see, because there's no kinds of summations, or there's no kinds of like elements, something like this one in here in our constraints. Something like, let me show you exactly. Uh, Something maybe like we have discussed earlier in the wagons situation. Yes, something like this one. And in here, we are just trying to write down the constraints so simply, and then we will get the result. This one, why didn't I just try to write this one? Um, you see, I have defined this decision variable in here as an int plus. And what it means, as I have told you earlier, means like it's a non-negative number. It cannot be some kind of negative integer or any kinds of float numbers. So I have defined the type of our decision variable for the CPLEX, and there's no need to write it down. But if I just like try to write down in here like something like int, and I didn't want to try int plus for any reasons, I should write down for all cons for, and cons for means constraint for, cons for xi uh, greater or equal than 0. And why is that? What does that for all means? This for all exactly means something like this one. This one in here actually could be written better in some other kinds. Something like, let me write it down real quick. Uh, exactly like this. So, okay, this can be written down like this, and the members elements are 1, 1, 2, 5. And yes, we should write it down something like this, and at the end we have to add a semicolon. So there's no difference between writing this like this or something like this, but I personally prefer writing it like int plus because it's much more easier. Okay, and then for running it, we are going to just simply, so I have previously tried to drag it on the configuration, run configuration, and I have discussed the process for you in the PowerPoint and also in the class. So I'm not going to talk about it again in here. And I'm just going to run the program in here, and so we can see the results. And yes, you can see the outline in here. The outline in here can just define our decision variables, our objective function with our constraints, how many constraints do we have, and in here, if there was any problems, if any problem occurs, in here it just shows us the problem. It can be a warning or it can be a problem. If it's something like a warning, it's something like it will tell you something like for example, some parameter have not been used. Let me just like try to define ti and make it equal to 145 and try to run it again. Already you can just see. No, this is not the kind of error that I wanted to. I'm sorry. It shouldn't be in here. It's a parameter. So I can just define it as a float ci, and yeah, this is the right type for defining a parameter. If it was an int, or if I want to define it as a int, so I will just write down int ti. Okay, I will discuss the other kinds of parameters in our next problems. So let's try to run this again. Okay, as you can see in here, we have one warning which is telling us the element ti has never been used, and it's correct. We can delete this. So it can be a warning in here, which can tell us something like a redundant parameter or definition or anything, or it can be an error, which can be a syntax error or other kinds of errors. For example, you have xi, that I should be a member of 1 to 5, but by mistake you have put something like this in here. For example, let's say cons 5, cons 4, and for example, all of the line is something like this, but there is, instead of x5, we have something like x9. We don't have x9 in the set of our parameters, right? So after running this, we will encounter a problem. And you can see the error which we are having in here, that says index is out of bound for array, which is 9. So after just like this is a redundant constraint, so I just try simply delete it and try to run it again, and believe me, the result will be okay, and it would be good to go.